Hi dear friends and viewers, in this video we are going to discuss about derive the expression for dipole moment of revolving electron. Dipole moment of revolving electron. So dipole magnetic moment or dipole moment. Derive an expression for the magnetic dipole moment. So children, what we know magnetic dipole moment? Magnetic dipole moment. What we write? M is equals to IA and N. N is the, for example, if I take a circular coil, N represents the number of turns and A represents the area of the coil and I is the current. So this is the what we know magnetic dipole moment. Magnetic dipole moment. So now we have to derive the expression for magnetic dipole moment of a revolving electron. For a revolving electron, we have to find out the magnetic dipole moment by using this formula. For that, we can go for one assumption. That is what already we know that the electrons are revolves around the positive nucleus. So for example, here we are saying now that the electron is revolving in this orbital. That should be having some orbital radius is r. Orbital radius is what? R. So let us consider electron is revolving around the positive nucleus, in particular orbital of radius small r. For example, children, here this is the point P. Once the electron is started from this point and again reaches the same point, then what you have to say? One revolution is completed or one rotation is completed. In that, for one revolution, the distance traveled by the electron, that is nothing but wavelength. That is what? For one revolution. For one revolution, the distance traveled by the electron is nothing but wavelength. In this case, that wavelength should be equal to the circumference of the circle. Circumference of the circle. Circumference of the circle. So what we know, r is the radius, then circumference is what? 2 pi r. 2 pi r. That's why the wavelength should be equal to the 2 pi r in this case. So we have one general formula is the children, V is equals to nu lambda. From that what rate? Nu is equals to V by lambda. Nu is equals to V by lambda. There what is nu? Frequency. That means what? Number of revolutions or rotations per 1 second. That should be what we call frequency. That is nu, I am telling, nu is equals to V by lambda. What it is? Nu is the S, frequency, and what is V? V is the velocity of electron and lambda is what? Its wavelength or distance covered. Clear? That's why here what right? Nu is equals to what right? V by 2 pi r. This is the expression for now frequency. This is for wavelength. And children, we know that I is equals to what? We write Q by T, general formula. What is I? The rate of charge, what we call? Current. That's why here we are taking electron. That's why I is equals to E by T. I is equals to E by T. So we know that 1 by T is equals to what? Nothing but frequency. That's why we write I is equals to E into nu. I is equals to E into nu. Then I is equals to E into what is nu? S. EV by 2 pi r. I is equals to EV by 2 pi r. So children, this is the wavelength, this is the frequency, and this is now current. Starting when I told you what it is, M is equals to IAN. M is equals to IAN. So in this case, here there is only one orbit. That's why we will take N is equals to 1. Here in this case, N is equals to 1. And A is what? Area of the orbit. That is what? Circle like a pi r square. Pi r square. That's why here you have to substitute the values now here. M is equals to I means what, children? EV by 2 pi R. EV by 2 pi R into A means what? Pi R square. Pi R square. What is N? We are taking value is 1. That's why here what we write? Pi cancel, R square cancel. Then what we get? M is equals to EVR by 2. So EVR by 2 children. So this is the expression for magnetic dipole moment of revolving electron. This is what? Magnetic dipole moment of revolving electron. Revolving electron. That is the children this one. So I hope you understand. This was a very easy one. When you have idea about the definition of current, frequency and wavelength, obviously you can easily derive the equation. Okay na? Thank you for watching.